Hello, beautiful people of the internet. Okay, so what we are going to do is create an extremely simple Android application. It is simply going to say hello world, and then we are going to build it and push it, deploy it to the Google Play Store. It takes some time to deploy apps to the Google Play Store, so you're not going to see it live at the end of this video, but you will get a gist of what the process is like. To get started with Android development, you're going to want to install something called Android Studio. Android Studio is an integrated development environment for developing Android apps. So here on the developer.android.com website, you'll see a top level menu item labeled Android Studio. You can click on that and you'll be taken to this page that will auto suggest which version of Android Studio you can download for your operating system. There's a ton of lingo in the Android community, just like there's a lot of lingo in any community. But the first thing I will highlight is this. Each version of the Android IDE that Google offers is given a special nickname, right? So the latest version of the Android Studio, the Android IDE, is labeled or referred to as Chipmunk. In a year, there will be a different nickname for the latest version of Android Studio. In 2 years, it will be called something else. But anyways, that's the first little bit of lingo I wanted to highlight. So you can install that. And once it's downloaded and installed, you should see some icon that looks somewhat like this. And you can click on the icon to launch it. And you should see this wizard pop up once Android Studio boots up. It's quite a heavy app. It's not lightweight, but it's a great learning tool. Once you have this wizard open, you can click on this button to auto-generate a boilerplate Android application. They have a variety of templates that you can choose from. The next little bit of lingo I will point out is this word activity. So an activity for the web developers who are listening or watching is the same thing as a web page. So you know how a web page will load UI elements, and then you will have style files associated with the web page along with JavaScript or some sort of scripting language that adds interactivity to the web page. So in the Android world, the corresponding term for essentially what a web page is on an Android device is an activity. So an activity is a screen that has UI elements on it that have corresponding styles and have interactivity available as well. In the web world, the interactivity is created using JavaScript. In the Android world, the interactivity is created using Java, or more commonly these days, a language called Kotlin, which I believe compiles down to Java. So anyways, we are going to choose this template, an empty compose activity. Compose is a set of libraries that make developing your UI a little bit easier. In the web world, this would be like using a library like React or Angular to develop your web application. You could go ahead and use the lower level HTML, CSS, JavaScript to build up your web application, or you could use a UI framework like a React or Angular. So in the Android world, one, I guess, analogous library to what React or Angular is doing in the web world would be a library like Compose. Here in this wizard, you can choose the name of your app. Here is the ID that your app will be given. This is a globally unique identifier. The name can be whatever you like it to be, but this package name has to be globally unique if you're planning to share it with the world. This is where on your computer, the Android application you are about to auto-generate will be stored. Here, you usually have the option to choose either Kotlin or Java. I don't know why Java is disabled, but anyways, we are going to develop in Kotlin. Kotlin has a ton of support, and I think it is future-proofing you from having to make a lot of annoying updates or upgrades to your app over the next 5 to 10 years. I was telling you about the lingo, right? So here's another little bit of lingo. I was talking about how each version of Android Studio is given a little nickname, right? The one that we just installed was called Android Studio Chipmunk. So Android, or the Android community, or Google gives another little nickname to each version of the Android operating system, right? So Android 7.0 is also referred to as Android Nougat or Nugget. And then Android 8.0 is referred to as Oreo. Android 10 is Q, blah, blah, blah. So you get the point, right? There's a lot of little lingo. I just leave that as default. Me having an app that runs on 98% of devices is pretty darn good. But we can click finish. And then here on the left is your file explorer. This confused me the first time I looked at it because it doesn't reflect what I see when I look at the raw directory on my Finder or whatever my file explorer is for my operating system. So this is because Android Studio automatically loads the files in your app project that are going to be used by you the most while you're developing the Android app. If you want to look at what your project looks like in its raw format, aka the same thing that you'll see when you look at it with your file explorer, you have to change the mode that the left section or the file explorer is within Android Studio to be project mode. And then you'll see exactly what you see when you're looking at your Android app files in your file explorer or your Finder. There is rubygems.org for the Ruby world, and then npmjs.org, if I'm not mistaken, for npm, right, the node world. So you can come to Google's Maven repository and you can browse all of the libraries that are available to you to import into your project. And you'll use the build.gradle file to specify which third-party libraries you want to import into your project, just like you would with the package.json or the gem file in the Node and Ruby worlds, respectively. So hopefully that gives you a feel for what you're looking at. The app folder is sort of like the source folder for the Node developers or the Rails developers. So this is where you're going to place most of your application code, right? So source, main. This is where you specify all of the tests for your UI, right? This would be like doing automated UI tests with Selenium or with a tool like Cypress for the Node developers. And then test is where you do your unit testing, right? All your unit tests should go in here, right? So there are conventions for how you should do things, right? Just like there are in the Rails world. So yeah, so when you look at an Android project or you inherit or join a team to develop an Android project, everything will be in pretty predictable places. The res folder stands for resources. This is where you specify all of the images that are going to be used in your Android application. Or here you'll have your dictionary for all of the various strings so that they can be easily translated. I am going to open this project that I was developing before I started recording in order to prepare. I am opening this so that I can cross-reference the code that I wrote as we add it to this boilerplate project that we just created together. So let me explain what we're looking at. So you remember that I said that activities were sort of like web pages. To give a web world analogy, you can have multiple pages on your website, right? You can have a home page, an index.html page, right? And you can have a contact.html page, right? That loads if you have like a server-side rendered website. And then for the front-end web developers who are watching, those of you who are familiar with React or Angular, you are familiar with the concept of single-page applications where you can have multiple views that load within a single web page. So you have similar concepts in Android development, right? So if you wanted multiple different pages, you would have different activities, and you can have multiple views that load within the page as well. The most common router used in React apps is React Router, if I'm not mistaken. And then the most common router used in Angular apps is NG Router, if I'm not mistaken. But anyways, that's just an analogy for you. So that explains the activity, and we're not going to use a router for this very simple application, but I'm just giving you the analogies, right? You could use, I think it's called a navigation controller in the Android world, right? That is like using React Router or NG Router. For the front-end developers who are familiar with components, right? The concept of breaking up your UI into little nodes or chunks, right? The corresponding lingo in the Android world are composables, or at least that is the lingo when you are using a UI library like Jetpack Compose. Yeah, so you can build up your UI by building up these composables and including various composables within other composables. Like for example, this is the root, right, on create. That's sort of like ng on create for the Angular developers, or this would be like component on mount for the React developers who have been doing React for like 3 or 4 years now. Hopefully that gives you an analogy. Now let me just paste in all this code. We'll copy this greeting composable, right? And for the web developers who are familiar with CSS and the style tag on a HTML tag, or the style attribute on an HTML tag, that is sort of like the modifier parameter or attribute for the text composable. Right here, you can specify the styles of how that node in your UI will be configured to look. Here is how we get a preview of our app, right? So we can come over here. Android Studio has various tools for being able to preview your application. And right here, you'll see this little loader right here, right? This will, if you look at the bottom tab, you'll get some hints as to what is going on with Android Studio if it looks like it's doing nothing. So here you can virtually create different Android phones or different phones or hardware devices that support the Android operating system. They don't always work all the time. Some of them will work, some of them will not. I guess some of them have bugs depending on the operating system that you're running the Android IDE or Android Studio on. But I installed this Pixel 4. Click this play button to run your application on whichever virtual device you have downloaded. By default, you're not going to have any virtual devices. Come here, you go to this wizard, you select which hardware device you want, right? You select what operating system you want to install on that device, right? You give it a name, you click finish, and then the Android Studio IDE will download all of the software that allows you to easily launch a virtual device with those specs running your application. So blah, blah, blah. You can click play, and you'll see here, right? It will launch a virtual Android device that's running your application. And then you can click this button to do debugging. You can click this button to stop it running, right? But here you get a preview of what the app will look like. You can turn your phone into portrait mode, landscape mode, and whatnot to see how it adapts if you're doing like responsive styling, which we will not cover in this video, right? So anyways, that's the super simple Hello World app. Now I will show you how to build and ship your Android applications to the Google Play Store. First, what you'll need to do is come up with a globally unique identifier for your Android application. This is sort of like specifying the name of your node package in your package.json file if you are planning to publish your code to NPM. The format of this identifier is reverse org syntax, if I am not mistaken. You know how when you have a website, you specify your domain in the following format, something like www.mywebsite.com, right? It's the same format, but in reverse order. You'll see this reverse org syntax frequently in Java land. The only important thing is that it is unique among all Android apps, because when a particular Android device is trying to launch your app, it needs to know exactly which app to launch, and it uses the application identifier to pick out the app. After you have that set up, the next thing is to generate a private key for adding digital signatures to each build you produce. This is a security measure, a security layer as I understand it, that allows you to verify whether or not you created a particular build or not for your application. and you do it like so. So in the build option of the top taskbar, you'll see an option to generate unsigned builds and signed builds. Only signed builds will be allowed to be added to the Google Play Store. There are two formats that you can build your Android app into: an APK or .aar file, or an Android app bundle or .aab file, if I'm not mistaken. I think the .aab format is becoming more popular. So we'll click next. Here is where you will decide where on your computer the private key that will generate the digital signature for your signed builds will sit. I will pick key store, right? We will call it awesome key, right? And we want to sign both production builds of our app as well as test builds of our app. Actually, we'll only do production builds. This is like in Rails, how you can run your app in test mode or in dev mode or in production mode. You can run your Android applications or build your applications in different formats or with different configurations. And those are referred to as build variants in Android land. So you see, this is the .aab file that we can add to the Google Play Store. And once it's in the Play Store, people can download it and use it on their Android devices all around the world, right? A potential base of millions, if not billions of people, if you actually come up with a cool app. So yeah, just to run through that again, I did generate signed bundle, and then it spit out a AAB file here in the app folder of my Android project. I can then come to the developer console, and once I'm signed up, it might take a few days for you to do all of the KYC that is legally required of Google Play. They don't want sketchy stuff happening. If sketchy stuff does happen on the App Store, they want to be able to track who did it, et cetera, et cetera, et cetera. So you can come here, create an app. We'll call this my application, just to keep it super simple. Then you can drag and drop your builds here. It will scan the build, make sure it's looking generally okay. You can review the release. Yeah, you just have to go through the checklist of, fixing any issues that are caught by their automated system. Right? For example, they want to have a privacy policy, so you're going to have to host some sort of website where you have the official privacy policy for anybody who happens to download this app onto their phone. Blah, blah, blah. They have a whole bunch of stuff that they'll ask for, but once you have it all taken care of, you will see your application available in the Google Play Store. And that is the high-level gist of how you build, ship, develop Android applications, or native Android applications at least.